I can fight monsters, I can't fight physics.
Hello, Mustafa. So, got to do a bit more context for this question, but let's just, like, for example, give me 5.1, 2, and 3, see what you did. But let's see if I can sort of decipher it, what's going on. So this is AQA AS Paper 1 2024. Okay, so figure 15 shows a second lamp L2 identical to L1 connected to the circuit. So let's assume, or I'm assuming, or I'm guessing, a bit of a calculated guess. I'm pretty sure I'm going to be right. Let's say this was the original scenario. Okay, so now what they're telling you is, so R is adjusted so that the PD across L1 is again 3.3 volts. So let's have a think. So therefore, let's call this V1 and let's call this V2. All right. So V2 was equal to 3.3 volts. So that's what I'm guessing. Now, if you add L2 in parallel with L1, then our total for L1, L2 now decreases. Okay, because when you add something in parallel, the total resistance decreases. So that means V2, which was originally 3.3 volts, now decreases. Okay, so that's what common sense tells you. And if V2 decreases, V1, which is also the voltage across R, increases. There they're saying, well, what change can you do to make V2 back to 3.3? So how could you make V2 increase? If you want to increase V2, so therefore to increase V2, the only thing you can do, because don't forget V1 plus V2 is equal to 9 volts, that's Kirchhoff's second law. Some of the EMFs equals some of the PD. So to increase V2, you have to decrease V1. Now, how do you decrease V1? How do you decrease the PD across the resistor? PD is the energy loss, so you have to reduce the energy loss when it's going through the resistor. So what you have to do, you have to decrease the resistance. So therefore, R decreases. So I'm guessing that's what the question prior was. This was probably 5.3. Okay, and therefore, sort of, hopefully, that is the correct answer. In future, give me a bit more context, please. Thank you.